Welcome to the second session of OMFIF's Week with the Federal Reserve. Following yesterday's opening session with Federal Bank Presidents Patrick Harker, James Bullard, and Robert Kaplan on macroeconomic developments and recent monetary policy outlook, we are pleased to turn today to the topic of artificial intelligence and machine learning and the impact of these technologies from an economic perspective. Before we begin, let me reiterate our thanks to the Federal Reserve Bank of Philadelphia for hosting this Fed Week with us. I am Patricia Haas-Cleveland, U.S. President of OMFIF, and I'm especially pleased to welcome a very distinguished panel of experts with us today. Simon Frieldenhoeven is machine learning economist at the Federal Reserve Bank of Philadelphia, where he's been leading the bank's research efforts on AI and ML, and I will return to him in a moment to make opening remarks. Nitin Gore leads IBM's financial services research practice and previously served as founder and director of IBM Digital Asset Labs. He's also founder of IBM Blockchain Lab and CTO of IBM Mobile. Amit Gandhi is Wharton Professor at the University of Pennsylvania and Chief Economist at Microsoft Azure. Amit has published extensively on a range of econometric topics. Before we begin, just a reminder that today's session is on the record and also that we welcome questions, so please do submit them in the chat box and we will turn to them after the panelists have made opening remarks. To focus our discussion, we will start with some practical implications of the use of AI in today's economy, impacting business, the consumer, and society as a whole, including some unintended consequences and the implications of what's become known as algorithmic fairness. To kick off our conversation, I'd like to quote a recent headline from The Economist: "Bias in, bias out." The article notes that fixing demographic skews in training data would make models more fair. ML models can respond to almost any pattern, including ones that reflect discrimination, yet ironing out all traces of bias is a daunting task. This is a very timely backdrop to our topic today. I'd like to now turn to Simon, whose leadership at the Federal Reserve Bank of Philadelphia has looked at the question of biases embedded in many of the algorithms used in our financial sector. But first, to begin, it would be very useful to set the stage with sort of an overview of exactly what do we mean today when we talk about AI and ML, and particularly with regard to how they are being adopted by companies for decision-making. So Simon, over to you.
Thank you so much, Patricia. Before I start, I should say that the views are my own today and they're not necessarily like those of Philadelphia Fed or the Federal Reserve System. So the standard kind of disclaimer applies. So I want to spend a few minutes to get us started to just define machine learning and artificial intelligence. And then hopefully we can turn it towards a more economics discussion towards our panel. So let me share. Share my screen. There you go. So I want to take a few minutes to go over ML and AI as a field in general, define a couple of concepts and maybe clarify a few common misconceptions as I see them. And then I think we'll be bringing in more economics during the panel with Nitin and Amit. So clearly, you know, about 10 minutes I have to open the stage here, I'm not going to be able to cover an awful lot of ground. So I want to focus on 3 points. So first, I want to briefly talk about whether we should think about the advancement of ML and AI as sort of an evolution or a revolution. So is this a sudden leap where we all move into the next century, or is it really something more mundane where it's a gradual evolution and it's not quite as exciting maybe? I then also want to briefly talk about the distinction between ML and AI. In many ways, I don't think it's always that helpful to try to distinguish these concepts, but maybe today would be a good time to at least set the stage a little bit and distinguish between those two concepts. And then sort of related to actually the first point here, I also want to briefly talk about the adoption decision and think about whether it's really a kind of binary decision where we really take a big leap of faith and we can full on adopt AI, or whether we should think of that too as a more gradual process on the business side. So to answer the first question, the sort of standard way in the field to demonstrate your current AI capabilities are actually games usually. So today, these are video games. So Microsoft has sort of a startup that recently sort of beat, I think, everyone at Pac-Man, or so set the world record at Pac-Man. A few years ago, what was big in the news was that it was the first computer algorithm that could beat the world champion in Go. And traditionally, and this is the picture that you see down here, chess has been sort of the main vehicle to demonstrate the current state-of-the-art artificial intelligence. Okay, so this was sort of the way to demonstrate where the current state-of-the-art is in terms of artificial intelligence for probably the better part of 4 or 5 decades. And we think about this chess game in 1997 here, where Deep Blue, developed by IBM, beat Gary Kasparov, who was at the time the world champion in chess. It's not the case that IBM, found the holy grail of AI in 1996 and then developed this algorithm, and a few months later, computers beat humans at chess, and there was no looking back. So really, if you think about the history of human-computer chess matches, it goes back to at least the 1960s, where you have sort of respectable algorithms that could probably beat me. So the sort of layman who doesn't really play chess, but knows the rules, could probably be beaten by the late 1960s. And then sort of took 20 years until they started beating sort of masters. Another 8 years here, the British grandmasters beaten in tournament play. 1996, we have IBM developing the supercomputer Deep Blue, and it barely loses to Kasparov. And then a year later, so they add some more hardware, it actually defeats Kasparov. You fast forward another 10 years, and now you get to the point where the hardware isn't necessarily increasing anymore. In fact, now you have regular PCs, which have less computational power than the Blue did in the 90s, but it can defeat pretty much the best humans. So now it's mainly a development on the software side, the algorithm side. And today, I'm going to guess that Magnus Carlsen, who's the current world champion, would likely lose to his iPhone, assuming there was a good sort of chess software on there. So this is all to say, AI is not this kind of sudden revolution where suddenly machines are going to take over, but it's a much more mundane thing where sort of slowly progress and get better. And that ties to the next question. I think to distinguish between machine learning and artificial intelligence, which is sometimes in applications sort of a continuous discussion, the distinction is not always that clear, but really at the center of these AI systems are prediction tasks. And I think these individual prediction tasks you can think of as machine learning tasks. That's what they're good at, that's what they're designed for. And then the artificial intelligence step is to basically combine multiple of these steps where we have a predictive task, we have machine learning algorithm that's very good at predictive tasks. And we combine it in a clever way, generally using domain knowledge from experts to come up with sort of an end-to-end AI system. I think the last point is important here. Today, machine learning, in the sense that you give me a data set X and I predict an outcome Y, is pretty ubiquitous. And not only that, you can hire just about any college graduate with a, say, CS adjacent degree, and he's going to be able to do a decent job at it. What's much harder is then to combine these into sort of meaningful ways to solve the more complex problems you would see in many business applications. Maybe as a side note, I think actually a lot of economic models are sort of have the same flavor, where you have a couple of, if you ever saw a structural model or sort of more complicated economic model, you have a couple of linear regressions, and then a subject expert and economist will combine those to learn all the parameters and then combine them to be able to solve a more complex problem. So lately, I think the advances in AI are generally coming from improvements in predictive performance. And so at the heart of the sort of progress that we've seen in artificial intelligence is really the progress in prediction. So if you think back to the last decade or so, deep learning is sort of one of the big innovations in machine learning that has made these individual steps that make up this AI routine much better. We're able to come up with much better predictions now. But again, that is a gradual process. So every year we sort of do a little bit, push the benchmark a little bit. It's not that there's suddenly a giant leap. And I think that's sort of a running theme throughout. Now, of course, gradual improvement every year does mean that eventually you're going to have pretty large improvements, and that has large implications. So sort of an interesting side note here, I think, is this is a patent filed by Amazon. And if you look at sort of the next to the number 54 here, this is a patent for what they call anticipatory packet shipping, where they're basically saying, eventually we're going to be good enough to predict what you want. We can just ship it before you even ordered it. So, that is not, so this fact that we just slowly get better at predicting doesn't mean that eventually it's going to have a big impact. Okay. And then finally, let's talk about this sort of last question, and this is related to my first point, which is this adoption decision on a business as a business decision. I think today, these simple type of machine learning algorithms that just mean we can predict a given outcome or based on data are fairly ubiquitous. And the combination of several of these algorithms into end-to-end AI systems are probably less prevalent today. However, the adoption of either machine learning or AI, I don't think is a binary decision. We should think of this also as a continuum where the decision is how much do we invest in resources to come up with maybe a more data-driven decision-making, sort of lumping together ML and AI here into this term of data-driven decision-making. And again, as you sort of gradually get better at making predictions, you can think about the tasks or the scope of tasks where it's feasible or where there's a positive payoff of using these machine learning algorithms. It's going to slowly increase until eventually they sort of take over more and more of these steps. Now there's some interesting economics here in this sort of take-up decision, and maybe we'll get to that during the panel. For now, I'm not going to get into that, but I do want to sort of close this by getting into an economic example here to sort of tie it back to the discussion of today, which is credit decisions or credit scores. If you're in the US, you're very familiar with these credit scores, which essentially gives you a numerical value of how likely you are to default. The credit is extended to you. Outside the US, they may be less familiar with those, but just think about credit decisions in general. And these credit scores have been based on algorithms or a statistical model for a long time. So they've always been kind of data-driven in some sense. We just didn't used to think of that as an ML type of situation. So what they traditionally are the logistic regressions, or they're actually sets of logistic regressions, and where the variables that go in there are sort of a set of core variables, which is your payment history, the amount you owe, the length of your credit history, and a couple of others. And then you run a logistic regression. You're actually going to run a different logistic regression for different subsets of the population, and that gives you a credit score. And so that's been like that for a while. And today we're going to start to introduce, or there's sort of a hot topic today in this field, is whether we can introduce what's called alternative data, so other variables than these core variables. And so I think even here it's sort of clear that it's not a sudden plunge where we move from a completely non-data driven method to something that's completely determined by very complicated black box models, but we slowly add to the complexity of the model. So if you think about this sort of current state of the art, we made things a bit nonlinear. Would you consider that machine learning? I'm not sure. Eventually, if you get some very complicated model, you probably would. In a similar way, and you can keep adding terms to this or keep adding variables, right? You can add your checking account balance, which is something that's currently being done or considered by FICO, among others. You can take that a bit further and look at the history of your checking account balance. You can add past utility payments. So that's also something that you can now opt into with some of these FICO scores. And at that point, are you running a machine learning model? I'm not sure. If you take that further, you can look at sort of your past direct deposit that's been deposited into your accounts. You look at both the amounts and where it's coming from. That lets you infer who your employer is, what kind of job you have. Take that further, you take your digital footprint. You sort of see what kind of shopping do you do, what kind of phone do you own, use that. And then sort of you want to take that even further, you can think about adding an auxiliary model that estimates your parents' socioeconomic status to figure out if they could help you if you ever default for young applicants. And clearly, so once we move to these sort of bottom points here, you probably start to feel a little bit uneasy about these models and think maybe there should be some regulation there that thinks about what should be allowed and what shouldn't be allowed. So I think that sort of sets us up for a discussion hopefully we can have in the next hour. And with that, I'd like to turn it back to Patricia.
Thank you, Simon. That's a great starting point. And there's a lot of diving into we can do there. Before I turn to Nitin and Amit, just to follow up quickly, and I love your ending because it sort of answers in a way the question that I'm going to put out there, which is when you discover this sort of discriminatory patterns that is baked into some of the algorithms you're using in terms of the results, what can you do about it? And I guess that's really what we're going to talk about today, because trying to correct algorithmic fairness is not a straight and simple answer. Are there other examples that you have come upon in terms of your data sets that in your research where you've been finding this? I think credit scores is one that we tend to focus on the most, but are there other examples where you have found these examples?
Yeah, thank you. Absolutely. I think it's also hard to define algorithmic fairness in some sense. So I can give you a couple of different definitions of algorithmic fairness, and there's been a number that have been put forward. And so before we even I'm going to get to your question in a second. But it turns out they're mathematically incompatible. So what that means is that I can give you 2 or 3 different definitions, and a priori they all sound reasonable to you. But then I can prove to you mathematically that they can't all hold. So if you violate one, or if you satisfy one, you must violate the other one. And so then it becomes sort of a policy question. We have to sort of first of all think where we want to be. And so to make this concrete and give you an example actually that I've sort of looked at, think about mortgage applications for housing loans. In that space, you could think about just 2 simple regimes. You can have one regime where you say, okay, I consider a regime fair if the same proportion of white and black applicants are approved. So if I get sort of a 75% approval rate for both the white applicants and for black applicants, that seems like it's not a biased algorithm. That algorithm seems fair. You can also say, okay, I'm going to require that conditional on the same credit score, I treat white and black applicants the same. So everyone with a credit score above 750, for example, gets approved. Now, what's going to happen is both of those things can't hold. You can only have one of those 2 things. So then it's sort of this question where we have to sort of take a step back almost and think about what do we really mean by algorithmic fairness. And that's where sort of the lawmakers have to come in. It becomes an interdisciplinary approach, I think, where it's a discussion between policymakers, lawyers, to really define the concept in the first place before we can think about how to actually tackle it and help alleviate these biases.
Yeah, that's a great point because it sort of leads to the obvious, which when you say mathematically both can't hold, which is if you go in to adjust data to sort of correct certain biases, you may lead to other biases that are even worse or, other unintended consequences. And so the question of how do you ensure algorithmic fairness really comes back to what is algorithmic fairness or what is fairness? And I guess a question that's out there today is this something that can be regulated? How do you decide to your example that you just used there, which is the appropriate way to define fairness? Where do you, as an economist and obviously a mathematician, how do you sort of reconcile these in terms of how should this be determined?
Yeah, I mean, I think as I sort of alluded to, I think that very much needs an interdisciplinary approach. Then this is almost like an ethical kind of question, right? Where the math can tell you so much. It can tell you can't have either of them. And then it becomes a normative question, which one as a society do we want to enforce? Or where do we think is the right way to enforce it? I don't think there's a final answer. I'm not sure there ever will be a final answer, but I think it's very much an important discussion to have. I think that's beyond any doubt. I think we're in some sense very much at the beginning of it. Right now, the way these algorithms are regulated generally goes back to labor laws that are some 40, 50 years old, stemming from very much the analog age. So, I think it requires a discussion among fields. This involves mathematics, economics, law, statistics, computer science. And it's hard to have these interdisciplinary discussions sometimes. Right.
And I think everybody has to at least be at the same starting point and understanding what the question is in terms of looking at sort of the predictions at the heart of AI, as you said, and ML that is now generating these biases and understanding what's behind that so that you can say, is this fair? Is this not fair? Is this dialogue going on? Is there much work among disciplines to sort of tackle this?
Yeah, I think there is some work now. I'll also say it very much depends on the domain that you're in. I gave you 2 definitions. This is for mortgage applications. There's also debate in a completely different field now, in the field of facial recognition, where law enforcement in the US loses facial recognition sometimes to sort of detect who committed a crime. And there you run into very different kind of biases. So there, one of the issues is that these algorithms are trained on samples that are predominantly white, which means they have a much better performance at identifying suspects if they're white, which also means they're sort of just much better. They have a much lower false positive rate for white people. So that means is that they just get a lot of wrong, you get these kind of wrong convictions for minorities, just because an algorithm is that if you throw a big sample of data at an algorithm and it has a majority group and a minority group, the majority of the sort of training will happen on the majority group. So it'll learn very intricate relationships in the majority group, but it won't do very well necessarily on instances in the minority group. And so that's a very different kind of bias where it sort of becomes out of a very different mechanism, I guess, but that might require a different kind of regulation. So I think another complication here is that it very much is domain dependent. What is the right definition, depending on what we look at.
Right. But it also suggests that one of the aspects of this is to look at sort of the pools of data that you're examining, because if you end up looking at a data pool where the majority are all white, you're obviously going to get outcomes that sort of reflect that. So I don't know if the underlying data and data sets is something rather than tinkering with it per se, just examining, is this, is this a comprehensive data set to be using?
Absolutely. I think that goes back to the Economist headline you quoted earlier, right? Bias in, bias out. If you have a data set that's not very representative, then the algorithm is going to reflect that in some sense.
Yeah. We'll come back to this whole question of can you regulate algorithmic fairness, because what you first pointed out, which I think is the most important starting point, is that this is obviously very complicated and it requires a lot of different input and disciplines to interact. And so you need to at least understand that before you can then talk about, can you regulate this? But let's come back to regulation later. And let me turn to Nitin. So Nitin, as I mentioned, has been at IBM in a range of positions, all of which involve working with vast amounts of data. And I think one of the things we've seen is that companies in general are now using vast amounts of data to make their decisions, to target their consumer base, to understand their customer. And we see this from finance to retailers to the very large consumer-focused companies like Uber and Airbnb. And as we just were speaking with Simon, you can get these biases embedded in the AI and ML that you're using. And so how do you, Nitin, sort of monitor for these biases and data sets? And can you tell us anything about, from your experience, what you've seen in data sets in terms of biases?
Absolutely, Patricia, thank you. And I think I'd like to go back to a few things that Simon started his journey with in terms of it's an evolution. And I like to take a step back in terms of how we came to this point where bias is actually a question that we need to respond. And suddenly the conversation has moved from technical geniuses and technical curiosity to saying, okay, can this technology really harm us? So early on in my journey, of course, it was all about IT economics, the compute, the storage, the interconnect that makes all this possible. And now with the advent of the massive evolution that we've seen, both in amount of storage, both in terms of the evolution of ASICs and GPUs, in terms of compute power that's needed to process this massive amounts of data that's been created, I think has a lot of implications in terms of the ubiquity, as Simon mentioned, in terms of use of AI. I mean, AI is used for as simple things as understanding the books that you buy, which back in the day, we were trying to solve the bigger problems of the world. And suddenly you begin to see AI seep into every facet of our life. When we bank, we shop, every element of things that we do. And so while AI and ML has reached the economy of scale, my team has been focused on two things: quality and ethics. And I think I'm very proud to be an IBMer where we looked into sort of addressing this head on in terms of ethical AI as well as explainable AI, which then focuses on not just application of AI, but in terms of the consequential elements of the decisions that are made by AI systems. And I'll touch upon that in a few minutes, but in especially the domain that I'm focused on, financial services and digital assets, the domain is very compute intensive. We need massive amounts of data, massive amounts of storage compute capacity. And in many cases, we are trying to amalgamate the transactional data, which is data that has been trapped inside of many of the financial institutions and organizations, as well as exogenous data, which is the world outside, to sort of create that modeling element that makes the entire field of AI and the various disciplines that ML is governed. So again, the focus that my team is looking into is AI architecture, where we're looking into data domicile, data residencies, in figuring out as to how do we train these models. So now I'm going to tie the entire element of IT economics, is the economics of AI and how it affects the economic systems that we operate in, is figuring out the elements of how do we train the data, and that leads to where do you get the data from, the data domicile, the data rights, and that becomes a really sticky topic that even before we go into insights, that's a byproduct of AI and machine learning domains. It boils down to the raw materials that we have governance and control over, which is data. And in many cases, the training data, and this is something which Simon alluded to early on, just like our brains, we use a lot of training models to be able to train these models and then eventually use them in a more productive way to make decisions, whether these are insightful decisions or these are consequential decisions, like in case of credit scores, which affects our ability to draw loans and buy a house. I think in many of these cases, the training model becomes really, really important. So again, focusing on ethical AI and ethics in AI is focusing on that training model and having the back testing done with those training models that'll allow us to provide the validation of the thesis that we start off with. So I think in many cases, it stems from the thesis and proof points driven by the training that involves in proving out those theses and back testing it. And then eventually, constantly, focusing on explainability of every decision that the AI models make, I think will throw light upon the regulatory elements, but at the same time, in solving some of the challenges that Simon and you have described in the past. So I'll take a pause to see if that made sense. I know it was a long-winded response, but I just want to lay out the technical challenges and the history of how we came here and what is the path going from here going forward.
No, that's very helpful. Thank you very much for that, Nitin. I guess I would have one question about that. You said you want to have, sort of the proof point, and then you want to be able to back test it and see how that played out. But I guess as you're looking at these data sets and you're looking at the outcomes and you're training the data, and of course you said it's the raw material that counts. It all comes back to the same thing, the raw material that's going into this. Is there a role, as you do this, is there any human overlay in this process? And maybe it's part of the validation where you look at, what are the outcomes? What are they saying? That where you can sort of spot these biases and take a step back and then look at the underlying data that's being used, the raw material that's being used.
No, I think that's a great point. So I divide this into two elements, right? One is the source of data that emanates from us as humans. If I'm dealing with whether it's social media or whether it's Amazons of the world making shipping decisions, as was discussed earlier, or financial decisions, dividing into consequential, non-consequential. So for example, if a app tells me that it's recommending me to buy coffee or buy lunch, well, that's non-consequential. And we can't have human intervention because that defeats the entire purpose of having AI in the first place, is ability for us to have a balance between the human intervention and using AI do its magic and exploit the tenets of that technology in general. But in cases of consequential systems, which is financial systems, whether it's decision-making, law enforcement, I think in many of these cases, while there is a element of use of AI technologies in augmenting a human, whether it's a law enforcement again or financial professional, so we should look at that as human technology that we're trying to augment a human function, then completely replace it because there are consequences to some of these functions that are operating. And so the premise of ethical AI and explainable AI is exactly that, is that we are trying to again, augment a human function, and eventually the decision making should be relied upon these consequential systems on eventually a human being, because then there's a certain element of responsibility, not just in code, but responsibility of a human decision making process, as opposed to, let's say, lunch recommendation or shipping, because that is something which can be fixed in terms of customer service and what could be addressed. And that's the way we look at applying technology in the areas that have a larger impact, both in terms of societal and economic impact on our activities in our existing system that we operate in. And that will then seep into the lower hanging fruits or lower consequential systems like recommender apps and mobile apps and so on and so forth that goes into it. I think that may be an approach which may find the balance between not affecting us in the environment we operate in and start bringing in the principles of ethical AI and explainable AI into the system.
Great, thank you for that. Let me turn to Amit. We've covered a lot of ground so far, but Amit, you've said in some of your writings, and clearly you've spent most of your career focused on machine learning and AI in economics, but that to have an impact in these fields, you need lots of data. We've been alluding to the huge growth, not only in data, but in computing power and storage and all the critical things that go with that. Clearly, your experience with Microsoft Azure has exposed you to the vast amounts of data that are out there, and noting that a lot of companies are now more invested in looking at their own data, using their own data, starting to see a real return on their investment. As we referenced Uber, Airbnb, these sorts of companies, but they're also seeing these challenges, and we have been talking about these biases in different ways to think about it. So let me put to you the same sort of question we've worked on here, which is, can and how, if they can, these biases be corrected, these algorithmic biases? Clearly businesses, forget the ethical side or the impact to society or potential consumers who might lose out when you have biases embedded in algorithms. But clearly businesses have a commercial interest in trying to correct this so that they don't get bad business outcomes. What's your thinking about this, and how have you seen this in the data sets that you've been working with?
Great question and fantastic conversation, Simon and Nitin, and I fully concur with most of the thinking that's been already laid out about sort of the spectrum between predictions on the one hand and decision making on the other. And I mean, just the whole topic of why are we concerned about bias in the first place really, excuse me, loads onto the problem of decision making, because predictions are ultimately inputs to insight into the world and sort of analysis, but rubber meets the road when we're actually going to do something, sort of perform an action. And so I think, I think the pivot with decision making versus prediction also sort of helps us think about them between, and we talked about it a little bit earlier regarding ML versus AI, but if I go even more to the left, if I think about ML as being to the left of AI, is just software automation. And if we kind of think about automation has been happening for many years since sort of the advent of IT, ML is a form of software at the end of the day. And so there are tasks that ML can perform that can be codified in software. And AI, if I think about that, is closer to decision making, another class of software that can get embedded into computer systems and automate tasks. And so I think ultimately it's the scalability that provides an immense amount of the value. And I think that's really where this topic of bias then becomes prominent, because in a scalable environment, it's really hard to govern every micro detail. Really, you're governing things at the level of policies and programs at a more macro sort of vantage point. And I think it's really hard. I mean, I think fundamentally it's really hard. In my own experience, I mean, bias cuts both ways. I think we're concerned about bias. But at the same time, I mean, we don't want to starve these models of data. And I go back to what I said maybe in some of my earlier interviews. And if you just go look at the history of machine learning, the models themselves that really kind of broke through in like kind of circa the 2010 period, where we really started getting prediction accuracy up into that 95% sort of threshold for some critical baseline problems. The models, the architectures were known since, the 1960s, but what really changed was the volume of data, right? When you get past a certain volume of data, volumetrically, suddenly this sort of the performance curve starts to take off. And so I think we do have to be cognizant that these models, these architectures are very data hungry. And so the question of how you regulate bias, I think is difficult, because you don't want to starve the technology of its very oil that makes it operate. At the same time, bias can also be a good thing in the sense that it gives us human context. And I think in my own, and let me qualify that statement just a little bit, which is one of the tensions enterprises have with using data is the fact that, and let's give a people sort of complexion to this. So people in organizations who work on these models and put them into production, we will call them often data scientists. Okay, so there's a class of labor input inside of corporations and organizations, modern organizations that employ data scientists, and they are not typically domain matter experts in the topic being addressed, whether it's lending or it could be energy or some sort of retail phenomenon. I mean, they're masters in the models and the data systems. So for those outputs to have meaning, they often need human context. Now, how do you give it human context? That is sort of by definition bringing human bias into the models to make them perform better for a human outcome. And so I think as we think about the topic of bias, it's we do want some amount of sort of human context to inform the interpretation of the output to make it more usable. But we kind of, at the same time, don't want to perpetuate bad biases. So we can think about bad biases versus good biases. And I think it's a big source of tension in organizations because you can make heavy-duty machine learning investments and not see the payoff until you get enough human context to make it usable. And so I think it's a really it's a very challenging circumstance. Luckily, and I think Simon pointed this out, is there are ways of doing this, right? There are ways of approaching debiasing that don't necessarily involve curating the data, but really adding constraints. You sort of thinking about, if I want fair practices or fair outputs, these machine learning algorithms, they're all based upon some type of optimization of some kind of a function. And if we think that deviating from certain norms is a cost, we should add those costs to the formulation of the problem. The challenge, of course, is that it forces us as organizations and institutions to really codify our thinking, right? And a lot of decision making up until now has been intuitive, and we've used our intuitive systems to drive a lot of outcomes. We might process data intuitively, but the second we start to codify things, that formalizes a lot of our intuitions, and I think that's a big step for a lot of organizations. But I think the technologies are there. I think just the education and the awareness needs to improve to get to a better place.
Well, we've covered a lot of ground, and I'm glad you added that sort of human context, because I think at the end we're trying to find that balance between everything just being, done through algorithms and then sort of stepping back and having this look. Before I ask any more questions, maybe I should give each of you an opportunity to sort of comment on what some of the others have said, because I do want to come back to regulation, but we have covered so many important topics that I think need to be addressed before you even get to regulation. I welcome you all sort of commenting and expanding on some of your points.
Yeah, I'll make a comment on Amit's point, which I think was a prominent point, which is looking into the human context. So every time we create a model, which, in any of the disciplines around, machine learning, which is a bigger part of AI, we have a hypothesis, and that hypothesis leads to the types of data we need that goes into creating a model and then testing it and then eventually rolling it out. And I think that's where the entry point would be. What is the hypothesis that you set? And that hypothesis need to be tested. And that model then goes into, a constant learning mode. And I believe that element is where the bias sets in. So from a control procedures perspective, what we have been, or at least what I have been focused, or my team has been focused on, is looking into sort of stemming that bias at that point where the hypothesis itself doesn't start with the bias. And I'll leave it at that for now. But that's an important area, Amit, that you mentioned.
Yeah, I also want to just take us. I think Amit mentioned the sort of notion of perpetuating biases, and I think that brings up an important point, which is that we don't want to sound too negative in this panel either. Like, decision making that's reached by algorithms doesn't have to be any worse than that reached traditionally by humans. In fact, in many ways, and this was sort of the early days, we thought, oh, they're all going to go away. That they may not all go away, but in many ways, if you have sort of traditional data where a lender had lender officers who just didn't like giving loans out to minorities, the algorithm would realize that you have sort of a higher threshold for that and say that's not profit maximizing. We should sort of give out more loans to minorities. So it's not necessarily the case. Just sort of make that clear, and I think it is pretty clear to everyone here, but that algorithms don't necessarily make biases worse just by bringing them. That doesn't mean we can't do better and we shouldn't do better, but just sort of to caveat that. And I think it's also true, as Amit pointed out, that maybe it just makes us a little bit uncomfortable to have these sort of conscious choices of like, this is how much we put these constraints in there and say, okay, we want to get the best predicted performance under this constraint that we don't want to have this much of a difference between white and black applicants. That is a pretty uncomfortable choice, sort of hard code into an algorithm. But that's sort of one way to do it. And I think that's probably, in many ways, a sort of better way to do that for the reasons that Amit pointed out, that you don't constrain the algorithm itself, but you sort of put these, or you don't constrain the input, you sort of constrain explicitly the output and explicitly add these sort of fairness constraints into your objective function. Yeah. But it's uncomfortable.
Yeah, no, it's, I mean, but it does sort of fit the motif, I guess, of everything becoming code. And there's a lot of value to capturing logic as code, because once again, let's just go back to the essence of machine learning. It's sort of bias variance trade-off. And, human intuitive reasoning, we feel like we can get it exactly right, but that often comes at the cost of immense variance, right? And sort of reproducibility of output. And so I think as a business concept, it's something that we have to start to develop and sort of educate. I think one thing Nitin said that's really also sort of relevant at a practical level is this issue of data governance. I think data at scale, and we've already sort of referred to garbage in, garbage out. I think organizations that's an organization that lives on the cloud today has immense data, right? But they're swimming in data, right? And oftentimes leaders don't even know what data they have, what data they don't have, and what is the quality of that data. And I think this is a very complicated area, and Nitin, I would love your thought more on it. Just feels like there are not established canons and sort of standards of necessarily knowing what data is good, what data is bad, what data is usable, and if there are data quality challenges, because we talk about this bias problem. Volume of data is one thing, quality of data is another, and we're talking about petabytes, terabytes of data. How do we think about that in terms of the value of AI, the value of ML? Because a lot of projects can go sideways very quickly, as you've seen, when data governance is not really addressed appropriately. And it seems there's a bottoms-up way of doing it, which is sort of on a team-by-team basis, project-by-project basis. But what can we do from a sort of organizational, even maybe societal perspective to kind of drive better governance around data?
And I'm glad you raised that point, because it brings me back to the topic of regulation. And we do have a lot of policymakers and regulators who are participating in these discussions. And I think that we definitely, spoke about, we not only have the volume of data, but we had, which has been just exploding, but there's the question of the quality of data. And as Nitin said, we have to really look at the raw materials to get all this right. Is there a role for regulation in this, in all of this, in terms of governance, in terms of sort of setting parameters or guidelines in the field of AI and ML? And I think anytime when you're on the entrepreneurial side of the equation, you're always concerned that you don't want to be limited in your ability to innovate. And also, if you're a startup and you want to use AI and ML tools, you don't want to be up against the large companies that have lots of resources to devote to compliance for a lot of regulations. A small company doesn't have that, so they're very disadvantaged in that regard. But how should we be thinking about regulation? Is there a role for it at maybe very early days, since we're still trying to understand sort of the breadth and depth of the data concepts we're talking about? But I know in April, the EC first published a proposal for harmonized rules on AI. I mean, what do you think of these efforts? We talked about this briefly, but is this a starting point? Looking at them briefly, they almost seem more like rules of the road or sort of an effort to have industry best practice. But what's your thinking about regulation? I'd love to hear that from everybody. But Amit, maybe we can start with you, since you talked about, you put out there the point of governance.
Oh, yeah, sure. And I think kind of building on the theme, and we'll love to hear from the other panelists as well. But yeah, I mean, I think okay, so generally speaking, technology moves fast, as we know. And I think whether we want regulators to kind of intervene today is maybe a dicey issue, because it's unclear what we're supposed to do, right? So things are still evolving, the space is still forming. We're kind of in that, storming, forming, norming. I don't know where we are in that spectrum, but we're probably closer to still maybe storming a bit. And I think, but at the same time, I think it's important to start to put points of view together, sort of best practices, governance, because I think the issue that regulators have, and I think this happened with some of the last few technology cycles, is the technology runs away from the sort of the bandwidth of the regulatory body to even know what to do, and then they feel hamstrung by the sheer pace of business progress. And so I think efforts to engage in language, sort of establishing a language that can talk between industries, between organizations, between public and private sector. I think that's maybe the right starting point just to even begin the dialogue. I don't think we're there yet where there are levers that should be pulled, but I think the conversation needs to begin. And I think what is good about some of the efforts we've seen is at least, and some of this is international, not necessarily in the US, some effort we've seen to begin to establish some of that language.
Right.
And I would second that, right? I think it's interesting because I spent a lion's share of my career before moving into applying AI in various industries is looking into blockchain, where we're building this interconnected financial systems. And it made sense because the linkages of data with this transaction system made easy for us to apply AI to many of these blockchain models. And it became super easy for us to be able to say, hey, you have all the data sets in this one place, and why don't we apply this amazing technology to be able to create additional insights? And I believe, to your point, Amit, and Patricia, as you mentioned in terms of data governance, I believe that the framework should be around outcome, as it's hard for any regulator to begin to regulate every facet and every mechanics of how business is done. But if you regulate the outcomes in terms of how the data is used and treat data as an asset, which allows elements of privacy preservation as well as consent, I think that leads to the fact that you're stemming this problem from the source to say, if you really want to benefit and provide a dual benefit to the enterprise that's using this for their benefit, and you want to be benefiting from it, then you have to provide a consent which allows you to treat your data as an asset, whether you're deriving implicit or explicit benefits of sharing the data. I think having a framework, and we already have some framework in terms of fair lending practices and anti-discriminatory laws, which are the frameworks that are in place. We simply have to then go into the source of this framework to say there's an outcome, which is what EEOC and many of the fair lending practices do. And then you have the data as an asset, which is, again, an asset-based laws. I think that could be a much more sensible way to do than dealing with every mathematical aspect of modeling, which becomes enormously complicated and intrusive from a regulation perspective. So I'll pause at that and love to get Simon's perspective as well.
Yeah, I mean, I will wholeheartedly second that. You basically brought up both points I was going to mention. I do agree, as algorithms become more complicated, when we were in a world where it was a logistic regression, it was easy to say the coefficient on race has to be 0. Once these algorithms become inherently complex, nonlinear, have lots of variables in there, trying to sort of regulate what can go into the model becomes both incredibly burdensome and limits the way the sort of things we can find in the data. So then taking this outcome-based approach, I think, also is probably the way to go. it also, again, lets you sort of very specifically say, what do you want to achieve at the end of the day, and put that as a constraint in there, rather than sort of constraining some of the inputs and then hoping that it roughly gives out something that you like in the end as an outcome. And then the other thing I was going to mention also is that it's tightly linked, I think, to privacy issues. And Etienne also brought that up already. So sort of who owns your personal data as more and more of that sort of gets out there. And that's sort of a tightly linked discussion that I think is also right now very uneven across countries. So the EU has much stricter laws than the US, and that's a different issue that is sort of intimately linked in some ways.
Yes, I can't remember who said it, but somebody said, how can you talk about regulating AI and ML when the data underneath it is not regulated, or the regulation of that data varies? So it's obviously very complicated. So Simon, maybe your efforts to start at talking across disciplines, as you said, is a very important beginning. I think Amit pointed out the inherent dangers of moving too fast in regulation before you really even understand what the technology is and where it's going and the speed at which it's going. And Nitin, I think your suggestion is an extremely practical one in terms of how to think about this kind of in the initial stages. We are getting a lot of questions coming in, and one which says, can we please start letting the questions be asked? So I do want to turn to some of the audience questions. Here's a very straightforward one from Paul Sheard up at Harvard. He's saying, can the panelists define what they mean by bias, please? So a simple but an important question.
I would personally say that goes back to what I said in my earlier remarks, that it's hard because the concept of algorithmic fairness is not well defined without, or there's sort of multiple ways of defining that, and they're incompatible with each other, right? And this is sort of, I guess there's a one-to-one mapping in some sense between bias and algorithmic fairness. So I'm not sure there's sort of one true definition. Maybe this is something that's sort of my personal view. Maybe the other two panelists are going to disagree. But I think I can think of alternative ways to define it, and depending on the context and depending on your sort of normative stance, you might feel differently about that. But I'll let Nitin and Amit say they disagree with that.
Nitin, I'll let you take the next shot.
Yeah, no. I think to me, so here's the thing, right? In most practical scenarios, what we do when we do these modelings is we start with an outcome first. We trying to, so most of these AI models that we work with looks into what is the outcome that we desire, and then you work backwards towards it. And I think that's where you look into saying, what do I want to get out of this? And let me model my data, and let me model my neurons in terms of how I connect and add more complexity to this, this model to achieve the objective. And to me, I think bias lies in terms of the team or members working, and including the business objectives of what we're trying to achieve, whether it's low risk, high, lending models, or reaching, so to me, bias is the outcome. And the way we have designed these systems is outcome first and then working backwards, as opposed to saying, let the data be used as a fluid entity to be learned from, and let's see what comes out of it. In many consequential cases, I think. So I'll pause at that, and I'd love to get your thoughts as well on this.
Yeah, and I concur, and I think the question's a great one because, what is bias? And I think we do have to be really careful when we talk about it to really distinguish between the technical, maybe business concept of bias and the legal framework around bias. And I am not a legal scholar, and so I don't know the full depth and complexity of sort of the official legal definition. But I think when we talk about the debate on bias, it's pretty important, I think, to separate those. And if we thought about, now, if I just focus on the business technical bucket, mathematically, going to the outcome, there's an outcome, there's a target, and bias is going to be anything that systematically degrades your effect, your attempt to pin down that target. I mean, it's sort of in a very sort of mathematical sense of degrading some notion of predictive accuracy. And I go back to really the heart of a lot of machine learning is bias variance trade-off. So it's sort of built into the framework is the whole idea that I will entertain bias for the goal of reducing variance. And so, I mean, when we talk about machine learning and bias, it is built right into the DNA that there's something called I will bias with the goal of reducing variance. And so, and that's bad in the sense that, well, bias seems like pejorative and it's built into the framework, but it's good in the sense that it's there. It's in the technical definition. It's in the mathematics, and so we can control it to a large extent.
I'm going to go back to an earlier question that came in. We've covered some of it, but it's very much related to bias. And it says, explainability and biases are great examples of risks of AI. What are other examples of risk of AI for customers and institutions? Who wants to try that?
I think one of the biggest risks is, and we haven't really talked about that, but it's that the output or the outcome of an AI project is not typically known in advance. These investments, if you think about it from a firm investment perspective, are investments under uncertainty. And I think it's partly what distinguishes AI projects from traditional software engineering projects, where the business requirement or the framework that's going to be implemented is known ex ante, right? We are going to build this, and then the software iteratively goes off and builds it. With AI and ML, the output, the software framework itself is discovered in the process of developing the project. And so there's a lot of uncertainty in the bets people make in AI and ML systems. And even if you have a highly predictive rule, the rule may not be useful for all the reasons we've been discussing. It's biased, it's not interpretable, we don't know how to embed it in the organization. And so there could be a heavy investment put into an engineering practice that generates rules that are not usable in the end. And I think that's part of the business fundamental that I think we have to wrestle against as we kind of go into this space, is that there's immense uncertainty about what's going to come out the other end. And to help address that uncertainty, it's not just about the software. You need other competencies to complement the software. If we think about this from a capital and labor perspective, there has to be the right kind of labor that complements the software capital we're putting into these projects to really de-risk them as much as possible. But I think investment under uncertainty in IT becomes suddenly a major pain point that I think we're just starting to begin to address.
Yeah, and I would second that. I think what we've been working on, decision under uncertainty, is a big facet in financial services, which has been my focus in application of AI and various digital asset technologies. But then also this notion of technical debt. An average bank has between 12 to 1,400 data scientists. They all are siloed by asset classes and the various line of businesses. And we have this thing called AI, pipeline jungles, which is basically an output of one going to input another one. And let's say they change one model that has a downstream impact on risk model frameworks and liquidity management, so on and so forth. So I think the risk of some of these things is that the world is dynamic. So is the field of AI, and any changes in the way we design these interconnected systems can have a exponential impact on the ability. So we have now begun to look into a human-directed insight and human augmented intelligence, where we are looking into saying that, especially for explainable AI and consequential systems, is human-directed insights and saying, what do we need to do to achieve this? And then going after human augmented intelligence to use AI as an augmentation vehicle as opposed to replacing humans in these consequential systems. I think that sort of is one way to sort of mitigate the risk in using it, taming AI as opposed to letting AI take over in many, again, in terms of consequential systems. Let's stop at that.
Yeah, and maybe to add a sort of another dimension to this, I think there's another risk maybe that it's inherently based, or your models are inherently based on historical data, and then they sort of extrapolate what goes on forward. So I know that sort of talking to a payment processor during COVID, suddenly their fraud detection performed a lot worse because sort of suddenly things that look very different, and the model is trained on historical data. And if things sort of change, you want to sort of supervise it in a way that you can step in and not make sure things go haywire. To give you another example, I think there's a pretty famous example about two rare books on Amazon who sort of had algorithmic pricing set, and suddenly they were both, the prices went up to something like $1 million for each of these books, and it was just a simple book. So, in that case, it's sort of there's no one's really hurt by that. But you want to make sure that if you have an important decision made by a completely autonomous system, that it doesn't go completely haywire when something unexpected happens, I guess.
Let me point out another question that's come up that's related to something that we've talked about, especially Nitin. By regulating outcomes only, how would one know of any biases, et cetera, that could be built into the solution, especially when the outcomes are questionable?
So I would say that the outcome allows us to find the impact and effectiveness of these models. And if so, there's a notion of bias and variance, which I think Amit talked about earlier, is applying the same model with different data sets, and what's the variance, which is basically the deviation from the intended outcome of that particular model. And I believe sooner or later, whether it's going after inefficient AI architectures, which is basically how we connect these different AI machine learning systems and the data that feeds the system, or looking into an investigation that goes and saying, how come this decision was made and what is the behind the decision? And suddenly now we look into saying, hey, it is this particular AI model that led to it. So by governing an outcome, I think you carve the path of the enterprise's burden of explaining a decision-making system should it come under investigative lens. And that's how I think that, again, the notion of variance, which is saying, if the model is right, and if the model has always given this, then is this a repeatable process? Or if it's, let's say, for example, unsupervised system, which learns on its own, which is a bit more complicated system, then what is the modeling technique and what's the data that's fed into it? So I think that investigative element will lead to, just like what happens today in HR systems and financial systems, there's an investigation that leads to the root cause analysis. And the explainability is an element of root cause analysis in these sort of automated systems.
Anybody want to add to that?
I'm just concur that yeah, and so I think what Nitin points out is that the process is maybe clear in the sense that we're looking at sensitivity of inputs and outputs and trying to sort of understand sort of drivers of how certain outputs sort of came to be. But I think the challenging part here is conducting I don't know if anyone on the panel has been part of this. I certainly have many times, an AI audit, or trying to understand how things came to be sort of in a root cause analysis sense. And I think this is where something Nitin said earlier around sort of technical debt and sort of the ops practices at the level of the teams. How are they building these things out? Because it's one thing to build them out and get the outputs that have the right predictive accuracy. It's a totally different thing to kind of be able to conduct a clean audit as to what happened. And that really requires new software practices. And of course, there are fields that have emerged, ML ops, I have heard about AI ops, but I mean, these are pretty new and frontier. And I think, maybe the top technology companies in the world are using them, but that is, for this to really work at scale and make this a practicable art of conducting an AI audit, I think there needs to be more dissemination of that capability inside of organizations.
Yeah, and that's a great point from an audit perspective too, Amit, because if you look at, like, for example, AML KYC, which is a age-old, beaten down sort of use case that we often talk that leads to SARs in the financial system, that leads to, so all these practices are not, it's the outcome that says you need to do these things, so you've done the best you can in terms of detecting fraud or money laundering in the financial system. And so what we've been going down the path is like saying that if there's a insight, or there's an outcome that this particular machine learning model spits out, for every decision a AI machine learning model makes, we are supposed to sort of capture, or in case of audit, as to what are the data points that has gone into that decision-making process. And just like what you would do for filing a SAR or keeping track of every transaction, I think for every decision that's been made by any of the systems, keeping a record of that will be a good audit practice, which will lead to, again, provenance of how these things have been made. I think is something which enterprise should begin to adopt as a best practice.
That's a great point. Let me bring up another one that's very much related to the discussions we've been having. Well, first of all, are we on the other side of the hype cycle? Has AI failed to deliver? And what's the next game changer, if so? And then along with that is discriminating bias is actually a goal of decision-making support system. Discrimination can be a good or a bad thing. How do we determine what is bad bias?
So as to the first question, I would say artificial intelligence or machine learning as a field is giant. And maybe it makes more sense if we think about this sort of hype cycle analogy for subcategories. You think about self-driving cars, and you can think about where are we on the cycle there. And I think depending on what aspect you look at, you're going to reach very different conclusions. Some things are more or less in the mature stage now, like some of these machine learning methods, they just spit on data set X, and some output Y comes out. As Nitin, as Amit, I think, said earlier, for about 10 years now, we get very good results at that. And so they were sort of at a pretty mature stage at this point, I would say. Others, like, complete self-driving cars are still very, very early. And then a lot of other things are somewhere in the middle. So to me personally, I think it makes more sense to distinguish the different sort of aspects that you might want to look at rather than think of it as a field as a whole, which just varies so much.
And I'll say this, right? This is a really good point, because as I think you mentioned, Simon, earlier, that oftentimes AI is nothing but automation at a much faster pace. And we've sort of confused automation in terms of saying that we have this model, let's keep automating every time we get the same set of data. But if you look at the generative modeling, which is basically the new field of what we've seen with GPT-3, is generation of, again, examples of creating characters and creating blog posts, which is not from a human, but from a software bot, which is true sense of general intelligence. I think that's where things become a bit more interesting, where we have now again, this is still a nascent area in my opinion, even though massive advancements have been made, primarily due to accessibility, availability of data, and the ASIC and advancement in chipsets. Though I think that the notion of the generative, adversarial networks, which is basically you're trying to create a model which has its own debate before it comes to a conclusion. I think that's a really niche area, which I think needs to be well understood as to how are we devising the adversary that deals with, making the case against or for something, which I think is a interesting area. But I think a lot needs to be understood about, how do we structure that in production case in terms of applying that technology to which could be good and bad. I mean, we've seen this in the last election. We've seen this in social media posts. There are bots who look like humans. They have faces, but they don't exist. That's a bad thing. But in many cases, you could do a lot more advancements in genetics and in material sciences and financial risk management by using the same technology. So you have both sides of that equation, I think.
Yeah, just on that point, Nitin, about generative data and technology as kind of a new field. Someone pointed out that the Grand Theft model video game was actually used to train self-driving cars. So clearly, this is another pathway. But again, maybe generative data can help address some of the biases that are, being perpetuated in other data sets. So, yeah, there's always new fields opening up, and I couldn't agree more with Simon. It's hard to generalize around the field as a whole. So that's, and I think most people would probably agree with that. And then the tail end of that question is, how do we determine what is bad biases? And it almost takes us full circle to where we started. And with Simon saying, you really need all these interdisciplinary fields to sort of have a look at this, because what might be bad for someone is not bad for the other. And as I forget who else pointed out, machine learning is basically about, using biases they all have biases inherent in them in terms of the output. But is this going to be a big societal question, how we determine what are bad biases, or is this something that within the community is recognized as a just a fact of life? That some are good and some are bad, but you don't really know how to define that.
I think it's sort of maybe in thinking about sort of classes. I mean, I love the idea that we're getting into classes of biases now, which is sort of another layer into things. But I do think it's worthwhile to distinguish between sort of automation of an existing human decision process. So there is some sort of human reasoning that we can capture in software, and now we're hoping that the software represents sort of the human intent. from efforts to use machine learning to really do discovery, like discovery of new points of view that sort of the human sort of reasoning system has not ascertained. I sometimes talk about this in other contexts as the local max versus the global max problem. Is that human intuition captures local maxima, sort of locally good solutions to problems relatively quickly, just through the evolutionary function of the brain. But it's very hard without data to sort of capture a notion of global optimality, sort of looking at things at a system level view. And so good versus bad biases, I think it depends on which problem we're trying to study. Are we trying to automate what we already view as an acceptable human solution, or are we trying to go off and discover new knowledge, new insight? And I think even the question, I think, means something different depending on the circumstance.
Yeah, I mean, I think also from a sort of mathematical perspective, if you just think about the sort of bias variance trade-off, what that bias there means is that for a specific individual, your prediction is sort of systematically off by a little bit. And I think a lot of the sort of algorithmic bias that we talk about in this discussion of bias and in algorithmic fairness is more whether sort of for individuals in a protected class is on average that bias sort of has the same direction. So it's sort of more of a group bias situation that we care about there. And so, as Amit pointed out, inherently in these algorithms at the individual level, you face a bias variance trade-off, where you need to introduce a little bit of bias, otherwise to get a good predictive performance. And then the question is sort of whether that correlates with something like group membership, whether these biases sort of, then if you aggregate them up to some group level, which is a protected class, be it race or gender, if that sort of introduces biases there. And then again, the question is, how do you even define bias at that point? Is it that, going back to this example of credit decision, if I apply for a loan and you sort of find that the default rates for approved applicants is different by classes, is that the thing you want to enforce? Or is it just, what's the probability of getting a loan? So there's sort of different ways of defining bias, I think, than at that group level. And that, again, goes back to the sort of interdisciplinary discussion. I think is a normative question that's hard to answer, that you can't answer with math. That's something you have to sort of think about it, that we just decide as a society, as policymakers, what we should really think about there as a bias.
Yeah, and it's one important thing Simon said there that I think is worth bringing up is that when we talk about bias, we're really talking about it at a population level, like to adjudicate bias and algorithms. It's not, which I think is different than when we think about it from a human perspective. Like I think bias in any one use case is really not even a relevant, I think, point for the performance of an algorithm. It's really, what is its behavior over a large class of examples? And I think that's actually another important distinction to draw as we sort of think about how would we adjudicate this in practice. So great point, Simon.
But I have a slightly different perspective on this piece, right? That it's all about context. So bias, like our socialization, comes from our upbringing, the country and the region we grew up, the culture that we, and all that leads to our perspectives, and that leads to bias because there are. And when we look into AI, there's a lot of human context, as you mentioned, Amit, that there's so bias in some cases is contextual in nature. That for example, while we may not want to be, we want to be colorblind about Afro-Americans and white and brown people like me. We also want to make sure that there are sort of health elements to the genetic disposition of, let's say, Afro-American versus a Caucasian, which has to go into medical decision making. In that case, bias will, so to me, it's context and contextual element of how we are brought up and how decisions are made, that it's very regional. And that's why I think AI cannot be universal as one model that applies to all. Just like we have diversity and we embrace diversity, I would imagine that AI would have the same path, if that makes sense.
I think that's basically a great closing statement. That makes a lot of sense.
No, I think that was absolutely fantastic. We've covered so much ground today, and we could really go on, but unfortunately our time is just about up. So I really want to thank each of you so much, because I think you're the perspective you bring to the table, and also just educating us about some of the work that's going on in this field and ways to think about it has been extremely enlightening. So thank you very much to our speakers. Also, thank you to the audience for joining. I just want to say I hope you will all join us tomorrow, which will be our third session of Fed Week. We will be talking about considerations of a U.S. digital dollar, and we are fortunate to have Congressman Bill Foster and three experts from the Fed, with the Boston Fed, the New York Fed, and the Board of Governors. So please join us for that as well. And again, gentlemen, thank you so much. This was a great discussion, and I look forward to continuing it in the future. So thank you very much. And thank you again, Simon, for the Philadelphia Fed hosting us.
Yes.
Have a good day,
Thanks,
everyone.
Patricia. Thanks, Simon. Thanks, Amit.
Thank you so much. Thanks,
Yep.
Tina.
Thank you
Great.
all. Bye.
Bye.